Yo, what is good, you guys? I don't know, that was so weird. Let me try that again. All right. Yo, what's good, you guys? It's your teacher, Mr. Lee, at it with a video today. It is currently Sunday, May 3rd at 10 a.m. Oh my gosh, I'm so tired. But let's go ahead and get to it. All right, so before we learn how to graph logs, we are going to want to recall how to graph exponentials because they're very similar. So an exponential graph usually looks like this. It can look different like that. Um, it can look like an exponential decay function too. So let's go ahead and I'm going to mark this as b is greater than 1. All right, and what if b is in between 0 and 1? Let me do a different color. Maybe I'll get this. It'll look something like this. So this will be b is in between 0 and 1. So the domain and range of this, they're going to be the same though. The domain is going to be all real numbers. So let's go ahead and write that. The range is going to be from 0 to infinity. And we're going to have a horizontal asymptote at y equals 0. And our parent function, our coordinates, are going to be 0, 1, and then 1, b. All right. So remember that logarithms are just the inverse of exponentials. So things are going to look the same pretty much, except we're going to swap x and y, and we're going to reflect it across the line y equals x. So let's go ahead and take a look at what logarithmic graphs will look like whenever b is greater than 1. So if we have a b greater than 1, it's going to look like this. Amazing, amazing. And this point right here is always going to be, this is 1, 0. And then we're going to have b. Sorry, I don't know why I paused. I was just thinking. We're going to have b, 1. So this is for b is greater than 1. And then if we have b is in between 0 and 1, well, we'll have something a bit different. We'll just have something like this. Get out my red pen. And there we go. This is if b is in between 0 and 1. The domain and range are going to stay the same though, and they're going to be just swapped with the exponential. So our domain, instead of being infinity to infinity, is going to be 0 to infinity, because that was the range of the exponential. And same with the range. So the range is going to be all real numbers. Oh, I'm forgetting a negative infinity. No one saw that. And instead of a horizontal asymptote, because that's a y equals, we're going to have a vertical asymptote to make it an x equals 0. And here are our points. So for our exponential, we had 0, 1. So we're going to have 1, 0. And instead of 1, b, we're going to have b, 1. So this is what you're going to use for your tables whenever you're doing your transformations. So let's go ahead and do 2 examples. All right, so here's our first example. We're going to want to start this like we always do with writing the transformations. So we have h, s, r, v. So first, we have any horizontal shifts? We do. We have +1 on the inside, so that's a left 1. No stretches, no compressions, no reflections, but we do have a vertical shift down 2 because we have a -2 on the outside. So now we need to write our parent function. So we got x and y. So we have 1 and 0, and then b, 1. So b is equal to 3 in this case, because because we got a base of 3. Okay, and let's go ahead and apply our transformation. So we have left 1, so we're going to subtract 1 from our x's. So we have 0, 0, and then 3 minus 1 is 2, 1. All right, geez, I got the sniffles. I'm not sick, by the way. I don't know. I'm just like tired. Got a runny nose. And then down 2, that means we're gonna subtract 2 from our y's. So we got x, y, and then 0, negative 2, and then 1 minus 2 is gonna be negative 1. So we got 2 here. So let's go ahead and plot this. We got 0, negative 2, and then 2, negative 1. So before we do this, let's go ahead and plot our vertical asymptote. So our vertical asymptote is going to move whenever we have a transformation left to right. So it's originally, the original is at x equals 0. So if we're moving left 1, the vertical asymptote is going to be x equals negative 1. So let's go ahead and plot that asymptote. And now we have a pretty clear picture of what this is going to look like. Just follow your asymptote until you reach your points, and then there we go. It's beautiful. And that's going to be pretty much it. Now we just got to write our domain and range. So our domain, it's going to shift over to the left one. So it's going to be negative 1 to infinity instead of 0 to infinity. And then our range is going to be infinity to infinity. And that's it for graphing this function. Let's go to the next one. All right, so we got graphing and analyzing this bad boy of a function. Same steps, let's figure it out. So we got to do Harry Styles, rocks, V-necks for our transformations. So first, we have no horizontal shifts. We have a stretch. We have a horizontal compression by 2, or by 1/2, whichever one you like. And then we have a reflection on the outside, so this is a reflection over the x. And then we have a vertical shift up 1. So let's go ahead and apply these transformations. So we have, like always, 1, 0, and then b, 1. In this case, our b, our base, is 1/3. So we got 1/3, 1. All right, so we have a horizontal compression by 2. So this is going to get a bit spicy, because that means we need to divide all of our x values by 2. So our y's are going to stay the same. We're going to have 0 and 1. 1 divided by 2 is 1/2. 1/3 divided by 2, well, that's going to be 1/6. And then we need to reflect over the x. So let's go ahead and do that. Reflect over the x means that we are going to change the sign of all the y values, all the y coordinates. So 0 stays at 0, and then 1 goes to negative 1. And now we go up 1, so we need to add 1 to all the y's. So 0 goes to 1, negative 1 goes to 0. So next thing, we're going to plot our vertical asymptote. So vertical asymptote, we had no shifts left to right. So this is going to stay x equals 0. So we're going to follow our y-axis here. So let's go ahead and plot our points. We had, let's see, this is going to be 1. So 1/2 is going to be right here, 1. And then we had 1/6, 0. So it's going to be like here-ish. So let's go ahead and follow this asymptote and just sketch your graph. And there we go. So let's do domain and range. We still have 0 to infinity. And then range is infinity to infinity. And that's going to be it for graphing logarithms. I want to see you in the next video where we talk about E and ln. It's good stuff.